What's up, guys? Welcome back to another graded assignment. Today we're taking a deep dive into enterprise-level network infrastructure, powered by a single Dell server. Big day. This is the system. Right now, this machine is running an entire corporate network, which is exactly as stable as it sounds. At the physical layer, we have a single Ethernet connection providing all of the upstream network access. From there, all switching, routing, and segmentation is handled virtually. So instead of having multiple pieces of hardware, we decided this one could handle it all. So overall, this system is handling routing, firewall, virtualization, and all internal services, which is a lot to ask of one machine. But it hasn't complained yet, so once we had the hardware set up, we moved on to the virtualization layer. We're using Proxmox as our hypervisor, which lets us run multiple virtual machines on one system. So instead of buying multiple servers, we didn't do that. Inside Proxmox, we created several virtual machines to simulate a full network environment. Each one acting as a separate system, even though they're all running on the same hardware, which is either efficient or concerning. We also configured multiple virtual network bridges. One handles external traffic, and the other is isolated for internal communication. This allows us to separate systems just like how we would in a real network. Very intentional design. Between those two networks, we placed an OpenSense firewall to control traffic between internal and external systems, so nothing moves unless we let it. This setup allows us to replicate real-world network segmentation, routing, and access control, fully within a virtualized environment. So everything is separated properly, and also running on the same machine. Now that the environment is set up, the next step is actually controlling the traffic within this network. Jake will now walk us through how the firewall is configured to enforce those rules.
Hey Professor Sean, this is Jacob Delso. I'm on a team with Michael Hathaway, Dave Moselle, and Justin Hanrath. I'm going to go over the firewall configuration for our firewall. Starting with the NAT, I wanted to show you how we manually configured this. I wanted to do this as a demonstration of our understanding of what NAT does, because OpenSense does configure it automatically, but I figured it'd be more impressive to show you a manual configuration of it. So I have it in hybrid NAT right now, which allows me to apply rules while keeping some of the automatic rules that OpenSense generates. How it works right now is that any traffic that passes out through the WAN interface that is from the LAN network has the private LAN IP addresses converted through NAT to a public WAN address that can be used outside of the network. Moving forward into the rules, before I get into this, rules on the firewall are interpreted from the top down. When the firewall encounters any network traffic, it checks that traffic against these rules, starting with the first rule and going down until it finds a match. Once it finds a match, it performs the action tied to that rule. This will be important very, very soon. For now, though, we're going to look at the ping blocking rule, or the ICMP blocker. This blocks any ICMP traffic destined for the WAN. However, it will allow any ICMP traffic that is internal to work. This would work by default too, because these internal clients on the LAN are actually connected to a virtual switch, which does not. The firewall is before or after the virtual switch, so it wouldn't touch the firewall. Moving forward, we have the HTTP rules. My first rule here is a rule that allows traffic from an alias to pass out through the LAN interface into the WAN. An alias, in my understanding of it, is just some domain names that you have tagged under a identifier, like here. Right now I have the domain names for Ubuntu's main distros, so I can pull updates without them getting blocked, because the update distros operate on port 80. Immediately after that, we have the blocker, which will block all port 80 traffic entering the network. entering the LAN interface. We then have the FTP blocker, which will block all FTP traffic coming into the LAN interface, and then our two default rules, which were on and created by default when OpenSense was installed. Moving forward to the WAN rules, our first rule here is what allows the VPN to exit through the WAN interface into the wider WAN and outside network. It is allowing port 51820, which is a unused port. Ordinarily, a port like this would be blocked because OpenSense employs rules to block ports that are not, recognized as regular ports. We now have the flip side of, or we now have the SSH blocking rule. This will block any SSHs that SSHs that exit the WAN interface, ensuring that are entering the WAN interface, ensuring that any external clients can't SSH into a device that is inside the LAN. This includes the router. We now have a global blocking rule that will block all IMCP traffic from any source to any destination, particularly the WAN interface, which would lead into the LAN network. So you can't ping anything on the LAN network. We now have the FTP blocking rule. This ensures that any traffic with FTP cannot flow into the WAN, basically blocking all inbound FTP traffic to our network. Last but not least, we have the port 80 filters. Again, they specifically allow traffic from Linux distros to pass through the firewall, while all other traffic is disallowed. Now I will demonstrate these rules for you. First, we're going to do our ping. You can see from a previous take that I was testing out FTP. As you can see, connection times out, which shows that it did not work. I'm going to go ahead and exit FTP. Hopefully, yep, there we go. I'm going to try to ping an internal VM right now. So I'm going to try to do .10.175. As you can see, I can ping my neighbor completely fine. Now let's try an external ping to the VM on the external network. As you can see, time's out. All right. For my next demonstration, I'm going to show you how FTP doesn't work. So you can FTP internal clients. Oh, you can't. Okay. You cannot ping or FTP local clients. That's interesting to me because I didn't think that the firewall touched these machines. I suppose maybe they do. That, or maybe there's some sort of machine or configuration on the other client that is preventing this from happening. But let's try to FTP the external one. Now what should happen is it should time out. As you can see, it's timed out, which means our firewall is blocking the rule. Moving on to my next demonstration, I'm going to go ahead and show you how the HTTP traffic filter works. So Linux update distros use port 80 to deliver their updates. So all we have to do is a sudo apt-get and then update. As you can see, it's connecting to the HTTP web servers, and it's finished. Now let's try to access another HTTP website. So we're going to do HTTP forever. Go ahead and try to access it. As you can see, immediately blocked. So that's it for the HTTP filters. I'm going to now move on to showing you the SSH filters on the WAN, which will require us to log into our external client real quick. So we're going to go ahead and log in here. Now that we're logged in, I'm going to show you the SSH rule, 168.10.176. As you can see, totally hangs. I'm now going to try to do a FTP, just, while we're here. This is also not going to work. It'll also time out because our firewall is catching those. Now let's try a ping to a internal machine. This also doesn't work, as per our firewall's rules, blocking any pings from the WAN. I believe this should conclude my demonstration. I'm going to go ahead and check, just be sure I've gone over everything. Yes, I have. In that case, thank you for watching. I hope you enjoyed it, and I will see you next class.
Of course, internal networks aren't very useful if you can't access them securely. So Justin implemented a VPN solution to allow controlled remote access.
Hey, this is Justin Hanrath. I'm going to show off the VPN implementation for our project. So OpenSense has built-in support for WireGuard, and that's what we used. First of all, I needed to create public and private keys on the external VM and on OpenSense. So here's the public key for the external VM. And then on OpenSense, you'll see this is the configuration for the VPN. Listening port on 51820. Click edit, and you can see here that it creates a it creates a key, public and private key pair here. See the tunnel address, the port, etc. Click cancel. And then setting up the peer, which is the external VM. We put in the public key from the external VM here. And there's the allowed IPs. So going back to the external VM, I'm going to show that I'm not able to ping the firewall or another internal VM on the network. So the firewall is 192.168.10.1. See, it's not really going through. We'll do end that. 6 packets transmitted, 0 received. And then I'll ping one of the other VMs. These are one of the internal VMs on the network. Nothing. I'll do one more. Nothing there as well. Okay, there's that. Okay. And I've done a sudo wg show, which should show like VPN information, which I'm not currently on the VPN, so it's not going to show anything. And here in the settings, I've actually configured the OpenSense VPN. You can go to this tab. Here's the private key of the OpenSense. There's listening port. Here's the peer. So this is what allows us to connect. There's the public key from OpenSense. And there's the allowed IP addresses. And then the IPv4, I just set up the address. So if I go ahead and connect, it's pretty much instantaneous. Then I can go back to my CLI and I can try to ping those IPs again. And now it goes through. So now I'm on the internal network. So I just pinged OpenSense, pinged. If I do the command IPA, it will show that, where is it? It'll show that I'm connected to 10.0.50.2. If I try to ping another internal device on the network, 192.168.10.175, that will also ping. And then if I try to do sudo wg show again, it should populate with something. So now it's got the public key, the listening port, everything that's being transferred. So everything is configured properly. And if I go back to OpenSense, I can go to the status of the VPN and it shows that both the interface, which is OpenSense on WireGuard, and the peer, which is the external VM, both are looking good, both are up, showing the sent and received. And I can even go into one of the internal VMs and I can try to ping the external VM. So there's the IP address of the external VM that's connected via VPN, 10.0.50.2, and you'll see from the internal VM, VM user 1, it's able to ping out. And here I'll show the IP address of this VM, which is 192.168.10.176. Okay, going back to the external VM, I can actually turn the VPN off right here. I'll do that, and if I try to ping out again to that 176 address, nothing. Absolutely nothing. 6 packets transmitted, 0 received. And I'll show from that 176 address pinging back, nothing on this end as well. That's about it for the VPN. Thank you.
With the firewalls and remote access in place, the internal systems can actually start doing something. Now Michael will show how the virtual machines operate within the network.
I will be discussing the virtual machines used in our environment. We are running multiple virtual machines in Proxmox, all using Ubuntu Linux for the client systems, along with an OPN Sense firewall that separates the networks. The machines are divided into internal and external groups. The internal machines simulate hosts inside of a protected network, while the external machines represent a system outside of the network. Here's an example of one of the internal machines. Using the IPA command, we can see that the IP address 192.168.10.176 is assigned to this machine. This belongs to the 192.168.10.0/24 private subnet we have set up. Here is one of our external machines. Here you can see that the machine has an IP address of 10.0.1.224, which is on a different subnet, confirming that it is outside of our internal network. Now, for step 1 of our initial testing, we can verify that our internal machines are able to reach the internet by doing this one simple test. As you can see, we have verified that our internal machines can access the internet. As shown here, the system is able to successfully ping an external address, confirming our outbound connectivity.
From a design standpoint, this is a highly controlled environment. From a hardware standpoint, we're just kind of trusting the process.